Hi everyone. So today we're going to do arc length, which is kind of like, it stems from the lesson that you learned back in like 7th or 8th grade about circumference. So circumference is the outside perimeter of a circle, right? So it's this piece here. And we know it's the formula C equals 2 pi r. So if I gave you a radius and say the radius was 3, then you would know, you would plug in 3 into the r, which is radius. And you would get 2 times 3, which is 6, and bring down your pi. Now you could say 6 pi if they said leave it in terms of pi. Or if they said to like the nearest 100th or nearest 10th, you would in the calculator put 6 times pi, and you would get 18.8. And that's about, right? So about 18.8. I don't like my symbol here, so it's about this. So in terms of pi, you would leave it as 6 pi, and if it said to nearest 10th, you would then do 18.8. Okay, so we're going to do something like this today. It's kind of the more advanced version of circumference. We want just a section, so just a little piece of the circumference. You could think of it like a slice of pizza. When you get a slice of pizza, you would get the crust. So the crust of the pizza, you're not getting the whole crust of the pizza. It's just the slice that you took. All right, so arc length, you're going to see a central angle. So the angle has to be in the middle. It's a central. And we're looking at the length. We don't want the degrees of the arc like we were talking about before when we had angles. So instead of like 60 degrees, 50 degrees, for the arc length, it's going to be in feet or centimeters or inches, something like that. All right, so what we need to know is the degree of the angle. So say the angle was like 30 degrees, and they need to tell us the radius length. So maybe 4 inches. And if you have the radius and the central angle, this theta symbol is your central angle. And we all know that r is your radius, right? So this red part of the formula, that's your circumference formula. All right, and then I'm going to add in something to your circumference formula, which is theta over 360. Now, it has to be in degrees. So yesterday, we were converting radians to degrees and back to degree, then from radians to degrees and degrees to radians. So today, we want to make sure everything's in degrees before we input it into the formula. Now, theta over 360, so say it was 30 degrees, you would have 30 over 360. And 2 pi, plug in the radius. And that's really all it is. S stands for arc length. All right, so let's do a model question. So model question 1. S equals theta over 360, 2 pi r. Plug in 60 for your angle, because that's what it says here. Your radius is 5, so you're going to do 2 pi times 5. 2 times 5 is 10, so you'll have 10 pi on this side. All right, 10 times 60 is 600, and over 360. Now we have to reduce this piece. So 6 goes into 60 10 times, 6 goes into 36 6 times. We could keep reducing. So they both have 2 goes into both. It would be 5 over 3 pi. All right, so that is your arc length. And it's centimeters, actually. Okay, so that was this question. I'm going to do the other 2 model problems on another video. Okay, so if you need more help with the formula, you can go back and rewind this video. If you want to see the next 2 model problems done, you could refer to the next video because it's going to take a little longer. All right, and then you could get started on the problems for today.